Hello. This presentation introduces types of statistics, variables, scales of measurement, and research designs. Terminology that we'll use for the remainder of the semester is presented, so I encourage you to revisit this video as needed throughout the semester. First, we're going to talk about two major types of statistics. In defining statistics, we're really talking about techniques used to summarize, analyze, and interpret data. Descriptive statistics is the first type that we're going to talk about. These statistics are used to organize and summarize data. The second type are inferential statistics. These are used to answer questions through analyses and interpretation. Descriptive statistics are most likely the ones that you've had prior experience and exposure to. These are things like the mean, which is also referred to as the average, median, mode, and frequencies. With inferential statistics, this is where we begin to focus on actual statistical tests. And in this course, we cover 8 statistical tests. One sample z-test, one sample t-test, independent samples t-test, dependent samples t-test, one-way ANOVA, also referred to as an analysis of variance, chi-square, bivariate correlation, and bivariate regression. There are 4 terms we're going to talk about in relation to types of variables, and they split into kind of 2 contrasting dichotomies. So the first pair is qualitative versus quantitative. Qualitative variables are non-numeric data where there are groups or labels. So ethnicity is a good example of a qualitative variable where you have Caucasian, African American, and Hispanic, for instance. Quantitative variables are numeric data such as height, weight, IQ scores, test scores, ACT, SAT, those types of variables. Now, the second pair of contrasting terms is discrete variables and continuous variables. Discrete variables are measured as whole units or categories. For example, the number of students in a class. There's 40 or 41 or how many ever students in a class, but there's not 40.5 students. We can't break that down into a more refined unit. We can't be more accurate than that whole unit. With continuous variables, we can break the units down into fractions. So height, for instance, you may say that you're 5'8", but we can actually be more accurate than that. We can talk about half inches or quarter of an inch. So we could say that someone is 5'8" in 8 1/4 inches. With weight, another example, someone may say I'm 180 pounds. Well, they are 180 pounds, but we could talk about, they're 180.2 pounds, or we could talk about 180 pounds and 2 ounces. So we can be more refined in our units of measures. We can look at fractions of that initial unit. With scales of measurement, here we also have 4 major terms that we're going to talk about. So we have nominal, ordinal, interval, and ratio. The nominal scale of measurement is where we're looking at categorical units. And so this is very much related to the types of variables where we have those qualitative variables that are non-numeric data. So ethnicity, again, is a nominal scale of measurement. It's a qualitative variable where we're focused on groups that, in contrast to the ordinal, can't be organized or ranked in a acceptable fashion. So one kind of rule of thumb that you can use in looking at is it nominal or is it ordinal is, would you offend somebody if you tried to put them in order? So if we're looking at college majors, for instance, if we try to say that one major is better than another major, we're probably going to offend whoever's in the major that we say is not as good as. And so that's where we're talking about the difference between nominal and ordinal. Now with interval, this is where we move into equal distances between quantities. So with ordinal, if we're talking about somebody who is running a race, so they're competing, and we could rank those individuals who ran the race. we could rank them as first, second, third, fourth. But it may very well be that the first person runs a mile in 6 minutes, the second person runs a mile in 6.5 minutes, and the third person runs a mile in 8 minutes. Now, as you can see there is not equal distances between those individuals. There's 30 seconds between first and second place, 6 and 6.5 minutes, but there's a minute and a half between 6.5 minutes and 8 minutes, so second and third place. So this is ordinal data when we're ranking those individuals, and it is informative. It tells us who came in first. It tells us the order of those individuals. However, there's not equal distances between first, second, and third place. Now, in contrast, if the first person crosses the finish line and suddenly that becomes our 0 point, and so then the second person crosses the finish line 30 seconds after, and the third person crosses the finish line a minute and a half after, now we focused on seconds as our unit of measure, but we're still missing what we would need for it to be a ratio variable. We're missing an absolute 0 point because our 0 point is not the start of the race. Our 0 point is when the first person crossed the finish line. In contrast, a ratio variable would be seconds of the entire race because the 0 point represents an absolute lack of racing or running. It's an absolute 0 point. Another example that we can look at for this is temperature. So we often measure temperature with Fahrenheit, Celsius, and Kelvin. With Fahrenheit and Celsius, the 0 points are somewhat arbitrarily set. And with that, they aren't absolute 0 points. In contrast, the 0 point for Kelvin is a very much absolute 0 point. Now, fortunately, we often aren't working with those types of data. We're not having to make those fine distinctions. And when we're picking tests later in the semester, really this difference between interval and ratio kind of becomes a moot point because what we're really interested in is this a continuous variable? And so continuous variable kind of incorporates interval and ratio into one group, and if it's a continuous variable, then you're going to use the same test, whether it's interval or ratio. Another way of looking at this, those scales of measurement, is this decision chart here. So first, do the numbers represent meaningful differences between participants? If the answer is no, then really we don't need to continue going because really we don't have a meaningful variable. Now, if the answer is yes, the next question is, can the numbers be organized to represent higher or lower scores on an underlying construct? So this is where we're looking at the difference between nominal and ordinal. If the numbers can be organized to represent higher or lower scores on a construct, then it is not nominal. It is going to at least be ordinal, if not, interval or ratio. However, if we cannot organize these numbers to be higher or lower scores on an underlying construct, if we say no to that question, then we have a nominal variable like ethnicity or gender or something like that. If we say yes, though, we continue down this decision chart. So the next question is, do the distances between the values represent equal differences on the construct? So again, this is thinking about that racing example. If we are timing the race, we're using seconds as our unit of measure. 1 second to 2 seconds is the same length of time as 2 seconds to 3 seconds. However, as we've pointed out, first to second place may not be the same amount of time as second to third place. So if we say no, the distance between these values does not represent equal differences, then we're going to go with it being ordinal. If we say yes, though, then we have two options left, either interval or ratio. And the way we distinguish between those is with the question, does 0 represent a complete absence of the construct? So again, going back to the racing example, if the individual in first place becomes our 0 point, so they cross the finish line, and then person 2 and person 3 come in, we took away the absolute 0 point. Because the absolute 0 point would be if we started timing the race as soon as everyone starts, because that represents a complete absence of racing or a complete absence of running. And so when the 0 point does not represent a complete absence, then we're going to go with interval. If it does represent a complete absence of a construct, then we're going to go with ratio. And again, as I said, a month or so into the semester, what we really focus on is picking the correct test, using the correct formulas, things like that. And at that point, these categories of interval and ratio really fall under an overarching term that we'll use of a continuous variable. And if the variable is a continuous variable, then we're going to tend to use the same test, whether it's interval or ratio. So this kind of fine distinction at some point will not be as important. I would encourage you at this point to pause the video, go into WT class. There's a folder in your stats course labeled in-class exercises. And I want you to go into there. There's an in-class exercise that says Chapter 1, Levels of Measurement. This is going to give you an opportunity to read through a few items and to think about, is this a nominal, ordinal, interval, or ratio scale of measurement? And once you do that, then in the next class, when we meet together in person, we'll go through them, we'll talk about the possibilities and the answers for that homework. I encourage you to use your book if you would like, refer back to this, rewind the video if it's helpful, or even work with a classmate. Really, that in-class exercise, and this is the case throughout the semester, the in-class exercise is a method of learning. It's an opportunity for you to further your knowledge and to better your understanding and your foundation in this. Because sometimes when I'm describing these, when I go through this flowchart, it seems fairly obvious. And I typically in class try to pick fairly obvious examples. However, when you're looking at more applied examples, real world examples, it's a little more gray a lot of the time. And so you need to use this knowledge a few times to really get a good handle on it. Types of designs. There are 3 types of designs that we're going to talk about: correlational, quasi-experimental, and experimental. With correlational, we're using naturally occurring variables to see how the constructs are associated. How are they related to each other? So an example that we would use is age and self-restraint. So how are we going to define those terms? Age is pretty obvious. We're just going to look at how old is the individual in regards to years or maybe months, maybe days. And when I describe it that way, you can easily see that I'm able to break down those units, right? I'm able to make more refined distinctions. I can say the individual is 6. I can say the individual is 6 in 1 month, 6 in 1 month and 2 days, 6 1 month, 2 days, 3 hours. So we can use smaller and smaller fractions of that initial unit. And so that gives you a clue to the type of variable we're working with, which is going to be a continuous type of variable. And then with the second variable, so we're looking at age, then we're also looking at self-restraint. In this case, let's say that self-restraint is how long can I leave the individual alone in a room with a chocolate cake? And we're going to measure that as seconds. And I'm going to look at these 2 naturally occurring variables. I can't control a person's age. I don't control how old they are. And I ultimately don't control how long they decide to wait to eat the cake. So I'm looking at these 2 naturally occurring variables, and I'm just seeing, what is the relationship? Is it that a 2-year-old immediately dives into eating the chocolate cake the moment I leave the room, and a 6-year-old waits 5 minutes, and a 10-year-old waits 30 minutes? Or is there no relationship between these 2 things? And the moment I leave the room, no matter how old you are, you dive into the chocolate cake. So that's a correlational design. I have 2 continuous variables. I'm looking at them in association with each other. How are they related? How are they connected? Now, with a quasi-experimental, I still have naturally occurring variables. However, one of the variables is a grouping variable. So let's stick with my cake design. So we'll look at restraint in eating a cake. And I want to look at, do men and women wait a different amount of time before they dig into the cake? And here, one of my variables is gender. It's naturally occurring groups. I don't get to control which gender the individual identifies with. And so if there's a difference between these 2 groups, it may be suggestive that one has less self-restraint. But again, I didn't get to control it. I didn't get to decide. I didn't get to use random assignment. And we'll talk about that more here in a minute in order to determine these groups. So that lack of random assignment is really what distinguishes quasi-experimental from experimental. With experimental, we're using random assignment and experimental manipulation. So let's say that I think I can train individuals to have more self-restraint. And I take 40 individuals and I randomly assign half of them, so 20 of them, to receive my restraint training seminar. And they go through it and they learn how to control their impulses and their urges. And the other half of individuals don't go through that same training. So they're my control group. Now I want to look at, are these two groups that I've created, that I've decided who's in which group, are they different from each other? And that's going to be an experimental design. Now, in that regard, you've heard a few terms that you may not be familiar with. One of the first ones is random assignment. With random assignment, it basically just means the participants are divided into groups by the experimenter. The researcher determines the groups. The researcher gets to decide if you're going to be in the experimental group, the group that receives the training, or if you're going to be in the control group who doesn't receive the training. We also have independent variables and dependent variables in an experimental design. The independent variable is the variable manipulated by the experimenter. So in this case, it's the training. And the manipulation is, do they receive the training or do they not receive the training? The dependent variable is the outcome measure. So again, sticking with our example, this is how long does the person wait before they decide to eat the cake. And so that amount of time, that measure of restraint, that's the way we've operationalized it. We're going to talk about that. So that amount of time that they wait becomes our dependent variable. And so with operational definitions, this is simply how do we measure or quantify our variables. So in this case, the independent variable, we have quantified the two groups via that restraint training. So did they receive it or did they not? That is our operational definition of the independent variable. The dependent variable, we have defined it as number of seconds that the individual waits to eat the cake. That is our operational definition. That's how we have operationalized this term, this variable, within our study. So it's nice to have this information. But what's more important is, can we apply it? Can we use it? Because again, as I said before, often the case is that it seems to make sense when it's explained, but at the same time, it often takes working with that information, kind of using it to get a good grasp on understanding it. And so with this, let's look at a research question. Does experience with calculus enhance performance in statistics? And we can address this research question with any of our three types of research designs. So correlational, quasi-experimental, or experimental. We can address it in each of those frameworks. So with a correlational design, we might simply say, okay, what is their knowledge of calculus coming into statistics? So we do a pretest. First day of the semester, just 20-30 minutes of the class is, please take this 20-item test on calculus to see how well you perform. And then at the end of the semester, we look to see, is there an association between calculus pretest and the student's performance on the final exam? And if there's an association between those two things, then it would be indicative that calculus, one would hope, would be predictive of better performance in statistics. Although, honestly, the math and statistics, it's not too hard, so probably not the case, but that would be what we would be looking to see. Is there an association between these two variables? And the student's knowledge of calculus coming into the class, again, is a pre-existing variable and it's a continuous variable. Now, in contrast, with the quasi-experimental approach, we're going to have a pre-existing group. So we're going to compare individuals who took calculus to individuals who have not taken calculus. So still, students come in day one, I give them a short questionnaire and I say, how many of you have taken Calculus 1? How many of you have taken Calculus 2? Trigonometry is kind of related, so maybe I include a question about that. And that gives me a sense of individuals who have taken one of those classes, and then my other group is individuals who have not taken one of those classes. But you can see from that example, it's not that I got to pick. The researcher did not determine the groups. In contrast, these are pre-existing groups based on decisions by the students to take those courses. And so this creates a situation where we can now say, is there a difference between individuals who took calculus and individuals who did not take calculus when we get to the final exam? The last type of design. With experimental, we can assign individuals to the group. So they come in first day of the semester and I say, all right, I want half of you to watch this lecture video on calculus. The other half are not going to watch that lecture video. And then I'm going to look at your performance on the final to see, does this exposure to calculus improve your ability to perform when we get to the final exam? And so here, the researcher has determined these groups. The researcher gets to decide who's in the experimental group, who hears the lectures on calculus. The researcher decides who's in the control group, who's not going to get to hear these lectures on calculus. And then at the end of the semester, there's a check to see, is there a difference between these control group and this experimental group in regards to their final exam performance. At this point, it's a good time to go back into WT class, and there is a second assignment which is labeled as the Chapter 1 in-class exercise, so it's in that in-class exercise folder. And this will give you an opportunity to really bring together the information that has been presented here. So you're going to be looking at a research design, trying to pick out the variables, decide which one's the independent, the dependent, and then in class, in person, on the next class period, we're going to go through those, talk about them, talk about the possible answer choices. And again, I encourage you, make use of the textbook while you're doing that assignment. Feel free to complete it with a classmate if you know somebody in the class. Feel free to review these lecture videos, to go back through parts of them and to look at them and see if there's information in the slides or in the lecture that was helpful to you, that would help you in deciding those questions.